So we're given these two scenarios. We have this point A and B is 350 kilometer west of A. So B is here, A is here. Now the first condition is that if they move towards each other, and I'll call their speeds R sub B and R sub A, then R sub A plus R sub B, their combined speeds, it's additive, times 1 hour is how much distance they would need to cover, which is 350 kilometers. So that's the combined rate, that's 350. So that's the first relationship. The second one is that B has to catch up a net of 350 kilometers. And the difference in their speeds is RB minus RA. So that's how much kilometer every hour that B is gaining over A. So if we multiply that by 7 hours, that needs to match with 350. So this question, you'll note here that we can actually get the difference in speeds right away. 350 divided by 7 is 50. And we don't even need this part. So actually when I was doing this, I was thinking, am I missing something here? But I'm not, and you're not either. And so it is an easy question, but this part is given to perhaps to throw you off, that maybe you have to do something more than that's required. But this is all you need to do, is actually this part, this part. And if you don't like this relative speed kind of a setup, then you can say that, let's say they both reach this point, and B takes T hours, and A also gets to this point. So R sub B, the rate of B times T, would be 350 plus the distance that A would have covered. Let me call that D. And that D would be R sub A, because A is starting from this point, needs to cover that D, and it's going at speed R sub A and times T. So if I replace that here, I get RBT. And note here, we're already given what T is. But the key thing is, if I move this over, this is where that relative speed piece comes in. So you can sometimes just set it up directly, saying that this is how these catch-up problems work. So matter of personal preference, it's really the same thing. This is just more efficient. So the answer here is just 50. The difference in their speeds is 50.